Hey everybody, Mr. Cox here. Hope you guys are doing good. We're going to go ahead and jump into another lesson on geometry transformations, and today we're going to look at rotations. Now, rotations are probably one of the more difficult concepts to wrap your mind around, especially being virtual and being online. So I'm going to show you a couple ways to deal with them and a couple of ways to kind of recognize what rotation has occurred or if a rotation has occurred, okay, and how to perform rotations on your computer, all right? So what I've got here is a little worksheet. I've got a little document camera here today, and because this is the easiest way, in my opinion, to teach rotations to a group of students virtually. All right, so let's just dive right into some examples here on this worksheet, and we'll teach it. I'll teach about it as I go through them, okay? So our instructions say graph the image of the figure using the transformation given. Remember what we start with. This first image here is called the pre-image, right? So I'm just going to highlight this guy in blue here. This guy right here is our pre-image. This is where we start, and then after we perform a transformation, in this case a rotation, that'll be our image. So we're starting here with triangle JQH. Now, as with every transformation, there's always a rule, okay? So our rule for this transformation is we want to complete a rotation 180 degrees about the origin, okay? So the way that a rotation works is we're taking this figure and we're going to rotate it about a fixed point. Well, in this particular problem, our fixed point is the origin right here. And as we work through problems in 8th grade, the majority of the ones that you'll see will have this fixed point at the origin. And excuse the gross sore on my finger. I burnt my finger on the stove. That's kind of gross. All right? But that's the origin. And so we're going to rotate this figure about the origin. So just by looking at it, it's kind of hard to wrap our mind around what a rotation 180 degrees about the origin would look like. All right, so we know what the origin is. That's our center of rotation. Now, let's talk about what it means to rotate 180 degrees. And so here, take a look at this arrow here, okay? Right now, this arrow, let's imagine if it's pointing straight up, it has not rotated at all. All right, so when I rotate it to its side, let's call this a quarter turn. All right. If I rotate it completely backwards, let's call that a half turn. If I rotate it one more, let's call that a 3/4 turn. And if we're back at the beginning, that's a full turn. Okay. So if I rotate this arrow 1/4 turn, this is a 90-degree rotation. Okay. 1/4 turn is a 90-degree rotation. 2/4 turn, or a half turn, is a 180-degree rotation. Okay? A 3/4 turn, or 3 turns, a 3/4 turn, or 3/4, right, would be a 270-degree rotation, and then a whole turn would be a 360-degree rotation. All right? So we've got basically the most that you'll see is we have 3 different rotation amounts. 90, let me write these out here. We've got a 90 degree, we've got a 180 degree, then we've got a 270 degree. Now, you've got also a direction that you rotate. You can go 2 directions, and those 2 directions are either the direction of the clock, which we call clockwise, or the opposite direction of the clock, which we call counterclockwise. All right, so if I'm turning this way, let's just do this. We'll use a red marker. If I'm turning my paper this way, I'm going clockwise. So those turns that I just made, this is a 90-degree turn clockwise. This is a 180-degree turn clockwise. This is a 270-degree turn clockwise, and then I'm back to where I am. All right, now if I go this direction with my turn, This is a counterclockwise turn, okay? So 90 degrees counterclockwise, 180 degrees counterclockwise, 270 degrees counterclockwise, then I'm back to where I started. So these directions and amounts are important to understanding how rotation works. Now, I'm getting somewhere with this, so just bear with me. All right, so back to problem number 1, we're going to rotate 180 degrees. Now, I want you to notice it doesn't give us a direction, and here's why. If I go 180 degrees clockwise or 180 degrees counterclockwise, it puts me in the same position. So you'll notice with 180 degree turns, it never really gives a direction because it always puts you at the same spot. Okay? Now, let's talk about what it looks like to rotate 180 degrees. So to help me do this, I'm going to use this little transparency here. Okay? It's a little transparency sheet. And basically what I've done is I have sketched out the coordinate plane. And that's that. All right, so what I'm going to do is I'm going to take a dry erase marker here, and I'm just going to highlight the points on this triangle. All right. Now from there, what I'm going to do is I'm going to rotate this guy 180 degrees, and it doesn't really matter which direction I go in because I'm going to end up in the same place. Okay, so let's look at each of these turns. So if I go a quarter turn, and I'm just going to go clockwise here, that puts my figure right there. So if you can see just kind of a sketch of it, let me see if I can kind of sketch out what it would look like. This would be my new triangle. That's a 90-degree rotation clockwise. Notice with each 90-degree rotation, our figure changes quadrants. All right, so this one, each quadrant is worth 90 degrees, right? So a 90-degree rotation moves it from this quadrant here. I'm going clockwise, by the way, for this, and it puts it here. So guess what? If I go one more 90 degrees, that puts me at 180. All right, and right here would be my placement. Now I'm going to try to line this up the best that I can. And what I'm going to do is I'm going to take a little pen here, and I'm just going to replot my points that I have. So I got one there. I've got one there. Where's my other one? My other one is here. Then I'm going to take these, and I'm going to connect the points. Okay? And there is our rotated figure, 180 degrees. Now, as with every problem that we work on, we need to label our new points, okay? So sometimes it's helpful to re-overlay this transparency here and just see. So this one here was Q, so when I go back around, so this one's Q prime, okay? And you should be, okay, so this one's H. This one right here is H. So when I rotate that one, yeah, so this is H prime. And then that means that this guy here is J prime. All right, and that is how a rotation works. Let's do just one more rotation in this format, and then I'm going to show you a couple of other little tricks, okay? So I'm going to erase my transparency real quick. And we're going to do number 2 here. So let's take a look at number 2. So let's take a look at our rule. We're going to be doing a rotation 90 degrees counterclockwise about the origin. Okay? So let's rotate this guy 90 degrees counterclockwise about the origin. Actually, before we trace it, let's just kind of take get an idea of what quadrant this is going to be in. All right, so I'm going 90 degrees, so it's going to move from one quadrant to the other, but the question is it going to be this quadrant or is it going to be this quadrant here? If I'm going counterclockwise, I'm going to be going this way. So my shape should end up in this quadrant here. If it were 180, it would be in this quadrant. It would be one more turn. One more term would be 180, and then one more would be 270 counterclockwise. But let's just see. Let's take our transparency, and let's take our expo marker here, and let's just mark our points. Sometimes it's helpful to just go ahead and label them B, S, L. And let's rotate it 90 degrees counterclockwise. So we're going to the left here, and we're just doing 1/4 turn, so that's 90 degrees. Okay, so I'm going to have a point there and there. So let's just go ahead and I'm going to plot one here. And I'm going to plot one here. All right, and then I'm going to have one here. All right, and let's label them. So this is B prime, S prime, L prime. All right, so I'm just going to go ahead and outline this guy with the marker. And there is my 90-degree counterclockwise about the origin rotation. All right, so there's some examples of how you could use a transparency to help you understand this. All right, but some of you are probably like, Mr. Cox, I don't have a transparency. I'm not sure how I'm going to do this on a computer if I can't rotate a transparency on my screen. All right, so this is where some algebra comes into play, some algebraic rules, if you will. All right, and so if you look above me here, right up there, you'll see these algebra rules, okay? And you can see my mouse pointing to them here. All right, and I'm going to show you how to use them on 3 and 4 here. So let's go ahead and take a look at 3 and 4. Let's just adjust this a little bit. Okay. So number 3 says, let's rotate this figure 90 degrees clockwise about the origin. About the origin. So first, if we're going to use these rules up here, I like to copy down the coordinates of my points of my pre-image. All right, so I'm going to start with B. B is at the point 1, 2, 3, 4, 5, negative 5, 1. And you're going to need a piece of paper to make this happen. All right, so let's go F here. F is negative 1, positive 3. H is negative 1, negative 2, and M is negative 4, negative 2. Okay? So that's what we start with. Now, we're rotating 90 degrees clockwise. So there are 3 rules here that'll help us figure out the coordinates of the new points based on whatever rotation we're going to be doing. So the first one is a rotation 90 degrees counterclockwise. This is the same as a 270 degree rotation clockwise. This one's rotation 180 degrees. And this one here is a rotation 270 degrees counterclockwise. So I'm going to be using this one. Let me just box this in so you can see it. I'm going to be using this one right here because I'm doing a 90 degrees clockwise rotation. All right, so what this means here, remember this is the point that we start with, and notice I'm looking above me here, okay? This is the point that we start with. These points here are the points that we start with. So I want you to notice what happens when our 90 degree clockwise rotation occurs. Our X and Y flip spots, okay? And then whatever the X was becomes the opposite, all right, of what it is. So let me explain what I mean. So B here, all right, I'm going to use a marker here. So X and Y are going to flip, okay? So my X was negative 5, and my Y was 1. So notice they flipped, but I'm not finished because my X has to become the opposite of what it was. So now so in this case it's negative, so guess what it's going to become? It's going to become positive. So we got positive 1, positive 5. Let's do the rest here. X and Y will flip. And whatever my x was becomes the opposite of what it is. So it's going to become positive 1 in this case. So h, they're going to flip. So -2, -1. And whatever my x was is the opposite. So remember, this negative here in our rule doesn't necessarily mean that x is going to be negative. It means it's going to become the opposite of what it was. And let's do m here. Okay, so m, and whatever my x was becomes the opposite. So now what I've got, folks, is I've got new points that are the prime points. I forgot to label the primes. This is the image now, and we can plot those. So let's go 1, +5 for b prime. I'm going to label them. 3, +1 for f prime. -2, +1 for h prime. And then -2, +4 for m prime. So -2, 1, 2, 3, 4 for m prime. And check this out. If I connect my points, I get a figure that looks like that. Okay, I get a figure that looks like that. All right, let's do one more example together. I know that this is kind of intense, right? These rotations, but let's just do another one together. Let's do number 4. So number 4, here we've got a rotation 180 degrees about the origin. Okay, so let's again, we're going to use our rule, and let's start by writing out our original point. So u is at -4, -5. H is at -2, -3. F is at -1, -5. Now, this rotation 180 degrees, the rule is the easiest of all rules, okay? So if you'll notice here, I'm going to move my box up, because now we're working with this one here, a rotation 180 degrees. All we do with these guys is we take our original starting point right here, which is x and y, and we just change the sign of them. That's it. So that's pretty simple. So let's go through here and do that. So u prime, just change the sign. So -4 becomes +4, -5 becomes +5. H prime, -2 becomes +2, -3 becomes +3. F prime, -1 becomes +1, -5 becomes +5. So now I'm going to take and I'm going to plot these. So here we got 4, 5, this is u prime. 2, 3, this is h prime. And then f prime is 1, 5. F prime. All right, and that is our new rotated 180 degrees figure. All right, so what I'm going to do is I'm going to take these rules here and I'm going to include them in classroom resources. I'll also include them on the assignment as well. And you can use those rules to help you with your rotation work. It's going to be the easiest way to do it, considering you're being virtual, okay? But hopefully you have a better understanding of what a rotation is, what it looks like, and how you would do one. All right, guys, have a great day.